Hello everyone, so welcome back again in the series of AVL through deletion. So in previous lecture we have discussed the right kind of rotation, that is R0, R1 and R minus 1 rotation. And this lecture we are going to learn about the left rotation, that's L0, L1 and L minus 1 rotation. I quickly revise you that in AVL tree deletion, we need to follow all the rules that we follow in binary search tree deletion. That three criteria: that node with a no child, node with one child, and node with two children. So if you have you want to delete a node that is not having any child, that means a leaf node, then you can directly delete it. If you are going to delete a node that have one child, right, so what you can do, you can replace the value with that particular child, right, and you can delete that child, right. So that is node with one child. And node with two child, in that we have two methods: successor method and predecessor method. So in a successor method, you replace that with in order successor, and in a predecessor method you replace it with in order predecessor, and you delete that particular specific node, right. So the same, this three criteria you need to keep in mind while deleting a node in AVL tree. Along with that, as an addition, you need to check the balance factor, because that might cause the imbalance in your AVL tree. So while you are checking the balance factor, if it is not balanced, if that node is imbalanced, that means you need to balance it. So there are basically two types, left and right rotation. In previous video lecture I have discussed R0, R1 and R minus 1. In this lecture we are going to discuss L0, L1 and L minus 1 kind of rotation. So let me quickly take one example and I'll explain it along with the example. So suppose I'll take one value, that is a tree. Suppose I am having 45, then 36 and 27. If I have 63 over here, then 72, then some 89, then here if I have 50, and along with that if I have something called 48. Okay, so if I check the balance factor as of now, so the balance factor for 48, it's a 0, 89 it's a 0, 72 it's a minus 1, 50 it's a 1, for 63 it's a 0, for 27 it's 0, 36 it's 1, 45 it's a 1 minus 3, that's a minus 1. Now this is as of now my AVL tree. Now if I delete 27, so that means I want to delete that particular node. So after deletion, what will, it's a leaf node, right, here I have taken the leaf node only, so you can directly go with this node with no child, right, so you can directly delete that particular node. So what I'll have, this 45, then 36, then I'll have 63 over here, then 50, then 48, then 72 and 89. It seems here that it is not balanced. Then also you can verify it by checking the balance factor. So for 48 the balance factor is 0, 89 the balance factor is 0, 50 balance factor is 1, 72 balance factor is minus 1. 63 balance factor is 0, 36 balance factor is 0, and the 45 balance factor is 1 minus 3, that's a minus 2. So here this node is not balanced. So now this is not your AVL tree, right? So this is your critical node, right? Now here I am explaining you that this is left kind of rotation, so you directly get that in this whatever example I'll take, that left kind of rotation only. But in a general, if you have, so how to identify that it's a left kind of rotation, I have also explained for the right. Same here I am explaining for the left, that you need to check from which side of critical node you deleted that particular node, right? So here you have deleted this 27. So this 27 is deleted from the left side of my critical node. I need to compare it from the left, right? So it has been deleted from the left side of my critical node. That means I came to know that this is a left kind of rotation. So it's a L rotation. Now in L I have three options, 0, 1 and minus 1. As I told you that what you need to do here, it's a left kind of rotation, so you need to check the balance factor of critical node's right child, right? Always you need to check the balance factor of critical node's child only, left or right. For that you need to check if that particular node is deleted from the left side. That means if that is a left kind of rotation, then you need to check the balance factor of right child, and if it is a right kind of rotation, then you need to check the balance factor of left child, right? Now here it's a L kind of rotation, so you are checking the balance factor of critical node's right child. Here in this it's a 63. So balance factor of 63, it's a 0, right? So now you get that it's a L0 kind of rotation, right? Now L0 rotation is nothing new, but that's your RR rotation, right? So just quickly revise what is RR rotation. That means if you are having a RR rotation, you need to rotate your critical node towards the left side. That means this 45 is my critical node, I need to rotate it towards the left, right? That is my RR rotation. So L0 is nothing but your RR rotation. So what I'll have, that if I rotate this 45 towards the left, that means 63 will become my root node. The right child of 63 will remain as it is, 72 and 89. The left child of 63, previously it was 50, but after rotation this 45 will become the left child of 63, and 45's left child will remain same, 36, and this 50 which was previously the left child of 63 will now become the right child of 45. So 50 I am having over here, and this 48 will remain same. Now if I check the balance factor, this rotation is done, RR rotation, that means it's a L0 rotation here. This is done. Now I need to check the balance factor. So for 89 the balance factor is 0, 36 the balance factor is 0, 48 the balance factor is 0. For 50 the balance factor is 1, for 45 the balance factor is minus 1, for 72 balance factor is minus 1, and for 63 balance factor is 1. Now here as you can see, this is balance tree. So this is now your AVL tree, right? So this is L0 rotation. So I hope you understood the L0 rotation. Now I'll explain you one more rotation, right? So you need to keep in mind that L0 is nothing but your RR rotation, right? Now let me have another example for the next rotation. So suppose I'm having this 45, then 36, then 27, then if I have 63 over here, 50, then 72 and 89. Right, I have done few modification only, nothing else. Right, now if I check the balance factor as of now, so the balance factor for 89, it's a 0, for 72 it's a -1, for 50 it's a 0, for 27 it's a 0, for 36 it's a 1, for 63 it's a 1 minus 2, that's a -1, and for 45 it's a 2 minus 3, that means -1. So as of now this is my balance tree, so this is my AVL tree. Now here also I am deleting 27, right? So if I delete 27, that means this node I want to delete. So after deletion, what I'll get, that 45 will be here, 36, then 63, then 50, then 72, and then 89. Now if I check the balance factor, for 89 it's a 0, for 72 it's a -1, for 50 it's a 0, for 63 it's a -1, for 36 it's a 0, for 45 it's a -2. So now it's not my AVL tree, right? Because the node gets imbalanced, right? So here the imbalanced node is 45. So 45 is my critical node, right? Again the same thing, I need to check from which side of my critical node that particular data is deleted. So 27 is deleted from the left side of my critical node. That means I come to know that it's a L kind of rotation, right? Now which one of L, 0, 1 or a -1? So for that you need to check the balance factor of critical nodes right side, right child, right? So here critical node 45's right child is 63, and 63's balance factor is -1. So it's a L -1 rotation, right? And again this L -1 rotation is nothing but your RR rotation only, right? So in a RR rotation, what you need to do is you need to just rotate your critical node towards the left, right? So if I rotate my critical nodes towards the left, simply what it will have, 63 will become my root node, 72 and 89 will remain same, 45 will become the left child, 36 will remain same, and 50, which were earlier it was left child of 63, will now become right child of 45, right? So it's done. Right, now if you check the balance factor, for 36 it's a 0, 50 it's a 0, 89 it's a 0, 72 it's a -1, 45 it's a 0, and 63 it's a 0, right? So now it's your balance AVL tree. So I hope you understood this L -1 as well, right? Now what is remaining, that is L1 rotation. So let me quickly explain you L1 rotation. So I'll take one example. So suppose I have this 45, then 36, then 27. I'm taking the same example with few modifications. So I can explain you all the scenarios. So here I'm having this again. If I quickly check the balance factor, 48 it's a 0, 72 it's a 0, 50 it's a 1, 63 it's a 1, right? 27 it's a 0, 36 it's a 1, and 45 it's a -1. It's my balance AVL tree. Again, what I'm going to delete, I'm going to delete 27 only, right? So if I delete this 27, what I'll get, that is 45. It's a leaf node, so directly I'm deleting it, right? If it is not your leaf node, it is some intermediate node with one child, so you can directly replace the value of that child and you can delete that particular child, right? And if it is intermediate node with two children, so you need to find the in order of it, and either you can follow the in order successor method or in order predecessor method. Now let me quickly give you the balance factor. So 48, it's a 0, 72, it's a 0, 50, it's a 163, it's a 136, it's a 0, and 45, it's -2. Now it's not your AVL tree, so 45 is your critical node. Again the same thing, the node deleted node, that is your 27, that is deleted from the left side of your critical node. So that's a L kind of rotation, and in that you need to check the balance factor of critical nodes right child, right, and that's a 1. So now it's a L1 kind of rotation. Now L0 and L-1 both rotation are RR rotation, but this L1 is not your RR rotation, it's a double rotation, that's a RL rotation, right? So RL rotation, that means what, you need to rotate the node below the critical node towards the right, and then you need to rotate the critical node towards the left. So here in this scenario, you need to rotate 63 towards the right. So it would be the first rotation. In the first rotation, you need to rotate the node below the critical node on the opposite side. So that's a 63 over here. So you need to rotate it towards the right. So if I do so, what I'll get, 45 will remain same, 36 will be as it is, right? Now here I have 50, then this 63 will become, because I'm rotating it towards the right, so 63 will become the right child of 50, 72 as it is right child of 63, and 48 I'm having over here, right? So this is my first rotation, right? Now this first rotation, now it is not yet end, right? This is only my right rotation. After this, I need to rotate my critical node, that is 45. Here I am having this 45. So I need to rotate this critical node towards the left. So if I do so, what I'll have, this 50 will become my root node. The right child of 50 will remain same, 63. 72 will be the same, the right child of 63. Now 45 will become the left child of 50. The left child of 36 will remain, left child of 45 will remain same, that's a 36. And this 48, which was previously the left child of 50, will now become the right child of 48. So after this double rotation, left and right rotation, this is my second rotation. So after this two rotation, what I am getting is this, right? And this is my final answer. If I check the balance factor, for 72, the balance factor is 0, 63, it's a -1, 48, it's a 0, 36, it's a 0, 45, it's a 0, and 50, it's a 0. So now this is my AVL tree, right? So I hope you understood this, right? You need to just keep in mind, that's your remembering point, that you have 3 L0, L-1 and L1 rotation. This L0 and L-1 both are a single rotation, that's a RR rotation, and L1 is a double rotation, that's a RL rotation. And if you understood this, then it would be very easy for you to solve any problem, right? So I hope you understood this left rotation and right rotation while deleting a node in an AVL tree, right? So you just need to do practice. You might think that it's a quite tricky, but once you practice and once you get to into it, it would be very easy for you, right? So I hope you understood it, right? Keep practicing this. Thank you for watching this video.